Hello, good morning. As usual, I'm Onella, and today we'll be talking about antibodies and JVP recombination. Now, JVP recombination is a very complex and difficult topic, so I just took out a little bit of the key points and made it in a way that is very easy to understand. So, stay tuned. Okay. So as we know, an antibody is divided into a variable region, a constant region. It has light chains, heavy chains. So in my diagram, the blue represents the light chains and the red represents the heavy chains. Now, both the heavy chain and the light chain has what we call as a constant region and a variable region. Okay, so the first block here is the variable region. Okay, and everything below the variable region from here for both the heavy chain and the light chain is the constant region. Now when we talk about constant region, we talk about whether the antibody is G, A, M, E, or D. Now that spells gamed. That's the mnemonic I like to use for my constant region. Whereas the variable region means that whether the antibody is highly specific or highly has a high affinity for an epitope of an antigen or some other pathogen. But the constant region determines whether it's A, an M, or E, Ig, and whether it can be secretory, can pass through the placenta, and so on. Okay. So like I said, we'll be discussing JVP recombination. So in JVP recombination, what we look at one of those strands of the antibody, one here. So remember, this is going to be the variable region and here is going to be the constant region. Okay, so if we were to do this, if I were to go on the next page right here, this segment will represent the variable region and this segment here will represent the constant region. Now, in the constant region, we can either have, like I said, we can either have gamed J, M, E, or D. Okay, and in the variable region, it's different epitopes or affinity for different epitopes that reside in the variable region. In the constant region, we can have mu, which stands for M antibody. We can have delta, which stands for D. We can have gamma, which stands for the G antibody or IgG. We can have epsilon, which stands for IgE, and we can have alpha, which stands for IgA. Okay, so that's what we can have in the constant region. Okay. All right, but in the variable region, we can have a variety of things. We can have there is what we call as VDJ recombination. VDJ. V stands for variable, D stands for diversity, and J stands for joining. So in this variable region here, we can have a variety of things. So that's the variable region. Can have a variety of things. So we have 40 variable types, 25 diversity types, and we have 6 joining types. So what happens? Firstly, the first thing that happens is that one out of the 25 diversity region and out of the 6 joining region, one of the D and J come together like this. So one of the D and J's come together. So we have one D and one J. So D and J coming together. And obviously we have mu, delta, gamma, epsilon, and alpha, which we haven't chosen yet. Still here. One of the D's and J's come together to form what is known as DJ recombination. So this is DJ recombination. Okay, but we still have our V, which we still have 40 V's, but here we have one D and one J. So this is the first thing that